Jobs arrive at a printer buffer at a rate of 20 per hour. And we're asked to find the printer service rate, so the expected queue size is not more than 3, and the probability of a new job requiring more than 3 minutes is not more than 0.1. So the arrival rate is constant. And we're asked about a service rate, which also is constant. And so this is the situation of MM1. And also, nothing more is said, so we assume that it's in steady state. And so we have these two constraints that we just test separately. We'll get different constraints on the service rate for each of these two constraints. The first constraint that we will test is that the expected queue length is less than or equal to 3. E of q infinity is less than or equal to 3. Well, we know that the expected queue length in steady state is r over 1 minus r. And when we multiply top and bottom by lambda s, we get that that's lambda a over lambda s minus lambda a. So if lambda a over lambda s minus lambda a is less than or equal to 3, and we know that lambda a is 20, then we have the inequality that 20 over lambda s minus 20 is less than or equal to 3. And that corresponds by simple algebra to lambda s being at least 80 over 3. That's the first constraint that we have to consider. The second constraint that we have to consider is that the probability that the steady state customer time exceeds 3 minutes is less than 0.1. The steady state customer time is the time for a new print job to arrive in the queue that was in steady state to be printed. 3 minutes is 1/20th of an hour. Well, in steady state, the queue has an exponential lambda s minus lambda a distribution. And so we need e to the minus lambda s minus lambda a at time 1 over 20 to be less than or equal to 0.1. Well, we can just take logarithms on both sides, and so this is equivalent to minus 1 over 20 lambda s minus lambda a is less than or equal to minus ln 10. And so just by rearranging this to isolate lambda s, we get lambda s must be greater than or equal to lambda a plus 20 ln 10. Lambda a is 20 and 20 ln 10 is 46.05. So this constraint is that lambda s is greater than 66.05. Looking above, the other constraint was lambda s was at least 80 over 3, which is much less. And so our overall constraint is that we need lambda s to be greater than or equal to 66.05, which is 20 plus the 46.05, and the minimum lambda s therefore is 66.05.
Dear U of A students, while Mike has supplied the content for these videos, there's significant unpaid effort that goes into producing these videos in the background. The folks here at Step by Step Probability are family people with young children that no longer attend school due to the COVID shutdown. Instead of spending time with our families, we have made arrangements to continue producing these videos for you. In these uncertain times, it would be very encouraging to see your support through our donation button at the top of the website. Any amount is encouraging and appreciated. Please donate if you can. Thank you and keep safe.